Good morning, children. How are you all? I hope that you all are safe at home. Yes. Shall we start the class today? Right. Now we are learning the lesson electric current and its effects, is it? Okay. Have you all completed your homeworks? Yes. Children, we have completed that electric circuit diagram, symbols, then heating effect of electric current, is it? So I have given so many questions to learn to read the page, the lesson. I hope that you have completed all those things. Okay. Yes. Now today we are going to learn about magnetic effect of electric current. Magnetic effect of electric current. Can you recall what you studied about magnets in before class? Yes, you know that magnets can attract certain substances such as iron, is it? Yes. So we are going to learn about electricity and magnetism. Okay, that is already we have completed electricity. In that we are going to learn about magnetism. Okay. See, to see that magnetic effect of current passing through a wire. Okay, so for that we need a 1.5 voltage cell, two pieces of insulated wire, small magnetic compass and insulation or adhesive tape. Okay, then first stripe the insulation from the two ends of both the wires. Connect one end of the wires to negative terminal of the cell. Secure the connection with the insulation tape. Okay, connect one end of the other wire to the positive terminal of the cell. Secure the connection with the insulation tape as shown in the picture. Place the magnetic compass near the wire. Keep an eye on the needle of the magnetic compass. Touch the free ends of the wires connected to the positive and negative terminals of the cell. So when the wires touch, the needle of the magnetic compass gets deflected. So we can conclude from this, when a current passes through a wire, it behaves like a magnet and therefore deflects the magnetic needle of the compass. Okay. When a current passes through the wire, it behaves like a magnet and therefore deflects the magnetic needle of the compass. Okay. Then about electromagnet. Okay. We have seen in this activity that the current carrying conductor behaves like a magnet. As a result, it can deflect a magnetic needle. So, an electromagnet is a device that acts like a magnet when an electric current is passed through it. It loses its magnetic properties when the current is switched off. In the place of a single loop of electric wire, as in this activity, we could increase the magnetic effect by making many turns of the wire. Okay, many turns of the wire. Okay, we could further increase it by wrapping the wire around a piece of magnetic material like soft iron. Generally, electromagnets that are used commercially have a long insulated wire wound tightly many times around a cylindrical core. A piece of soft iron in the core increases the strength of the electromagnet. Okay, increases the strength of the electromagnet. Do you know what is a solenoid? A solenoid is a long wire that has been wound many times in a tight coil around a hollow or solid core. It has a cylindrical shape. Solenoid is often used in electromagnet. Children, do you know Hans Christian Ørsted? Who is Hans Christian Ørsted? He was born in Denmark in the year 1777. He was both a physicist and a chemist. He is known for his discovery of the magnetic effect of electric current. He demonstrated that a magnetic needle gets deflected when it is brought near a current carrying wire. In the CGS system of units, the unit of magnetic field strength is given in the name of this scientist, that is Worsted, in his honor. Okay. So how to make an electromagnet and show that it attracts iron. So for that we need 1.5 voltage cell, iron nail, safety pin or made of stainless steel, okay, and a piece of wire. First, how to do that? Take a piece of wire and stripe the insulation from the two ends. Wind the wire around the iron nail. Connect the two ends of the wire to the two terminals of an electric cell. This is an electromagnet, okay. So after, just to keep nearby a pin or a what is the stainless steel you have taken, okay. So if you take a safety pin, what you can observe there, it will attract to the iron nail, okay. So what do you have conclude from that? Passing an electric current in a coil wrapped around an iron piece makes the iron piece magnetic. The strength of the electromagnet depends on the number of turns of the wire around the core and the amount of current passing through it. The more the number of turns, the more will be the magnetic effect. The iron nail attracts more number of safety pins when wrapped with a coil with the more number of turns. What will happen if the current passing through the coil is switched off? The iron piece will lose its magnetic effect, so that what you can see, it will stop behaving like a magnet and thus will not attract the safety pin. It will fall down. Is it? Okay. Next we are going to learn, that is to study the behavior of an electromagnet when the current is switched off. Okay. So you can say what we have used to, you attracted everything will fall down, okay. So what are the materials you need for that? An electromagnet, iron fillings, wires, cardboard and pencil cell, okay. Take an electromagnet, connect the free ends of the wire to the terminals of a pencil cell. Take a cardboard, sprinkle some iron fillings on it. Now bring the electromagnet near the iron fillings. Do the fillings get attracted to the electromagnet? Yes. Now remove the pencil cell from the circuit. What happened? All will fall down. Is it? So electromagnet loses its magnetic effect when the source of electric current is removed. The electromagnet loses its magnetic effect when the sources of electric current is removed. Next, about uses of electromagnets. Electromagnets have a wide range of uses in all sorts of devices. Can you say some examples? Electromagnets are used in cranes to pick up cars in scrapyards and also to separate iron from garbage dump. They are also used in loudspeakers, telephones, electric motors, used in electric fans and washing machines. Electromagnets are also used in electric bells. So now we are going to learn about the electric bell. An electric bell has an electromagnet that pulls a strip of iron which makes the hammer hit the gong to ring the bell. So what is an electric bell? An electric bell has an electromagnet that pulls a strip of iron which makes the hanger hit the gong to ring the bell. Don't forget, important question, okay? An electric bell has an electromagnet that pulls a strip of iron that makes the hammer hit the gong to ring the bell. Now we are going to learn about electric bell, working of electric bell.
It's time! How does an electric bell work? No idea. I did not invent it.
Oh, some.
To buy some merchandise, visit some.com.
An electric bell consists of a bell, an electromagnet, switch, battery, clapper, and a coil. When the switch is closed and electric current passes from the battery to the electromagnet, this leads to the creation of a magnetic field. This magnetic field attracts the iron arm of the clapper. As a result, the metal ball strikes and we hear a sound. Now, this movement of the arm also leads to the opening of electrical contacts. This interrupts the current to the electromagnet and causes collapse of the magnetic field, causing the clapper to move away from the bell. Now, this movement of the arm leads to the closing of the electrical contacts again. Thus, the cycle starts repeating itself. As it repeats rapidly, we hear continuous ringing. This is how an electric bell works.
Children, I hope that you have understand about this electric bell. When you push the switch of the bell, the electric current flows to the electromagnet. Electromagnet attracts the soft iron stripe. The hammer attached to the stripe then hits the gong, making it ring. When the soft iron gets attracted to the electromagnet, it no longer touches the screw. Hence, circuit is broken and thus turns off the electromagnet and it can no longer attract the soft iron strip. Next, the soft iron strip returns to the initial position, touching the screw. This results the circuit being complete and current flows again. So this continues. Okay, that's why continuously the bell is ringing. Okay, so today we have completed about magnetic effect of electric current. In that, what is electromagnet, then uses of electromagnets. In that we have learnt working of electric bell. Okay, children, today you want to read page number 203, 204, 205 and 206. Okay, question answers everything I will give through WhatsApp. So learn all those things. So today we can complete this session. Okay, so thank you children, thank you one and all, thank you.